All right, for today, we're going to be using our unit circle. Remember, I talked about this unit circle before, but the points that I'm going to be using in this case are the 0 degrees, 90 degrees, 180 degrees, 270 degrees, and obviously 360 degrees as well. So having my coordinate, I'm going to draw my unit circle. Like I said, the points I'm going to be using are the 0 degrees and 360 degrees. Keep in mind this is 0 and 360. My coordinates here were 1, 0. Coordinates here, the 90 degrees were 0, 1. My coordinates here at the 180 degrees were negative 1, 0. And here the 270 were 0, negative 1. Once again, I'm getting that from my unit circle. Okay? So what it means, and remember I mentioned that the x value and the y value basically represent cosine of theta and sine of theta. And I even said, think of them in alphabetical order, right? The first one, cosine comes before sine in alphabetical order. So if I was to think, let me create a graph, because I'm going to graph eventually. I'm going to graph this using degrees. Let me write a 1 here, and let me write a negative 1 here. At the beginning here, we have 0 degrees. Here, then I'm going to have 90 degrees. Then I'm going to have 180 degrees, 270 degrees, 360 degrees. I know my line continues to the right. I'm going to do it twice because I'm going to be looking at the graphs of cosine and sine. I'm going to be looking at both. Key degrees are 90, 180, 270, and 360. Now let's take a look at the graph of cosine. At 0 degrees, my sine is 1. At 0 degrees, my sine is 1. At 90 degrees, my cosine, my bad, I'm looking at cosine. At 90 degrees, my cosine is 0. At 180 degrees, cosine is negative 1. At 270, cosine is 0. And at 360, happens to be 1 again. If I was to look at my graph, cosine looks like this. So I'm going to call this cosine of theta. Now, what we see from 0 to 360 degrees in this case, we call that a period. A period means how long does it take for the graph to complete one whole cycle. I said my graph to the right continues, and what it looked like, it would look like my graph of cosine starts all over again. It's going to look like this. All right, it's going to continue. It's going to eventually look like a wave. However, let me highlight the one time that it went through a whole cycle. That's the graph of cosine. Like I said, to the right, it continues. If I was to go to the left, it should continue as well. All right, I'm going to continue like this, all the way to the left. That's the graph of cosine. Now, the graph of sine, let me graph sine. Let's do this in green. At 0 degrees, sine was 0. At 90 degrees, sine is 1. At 180 degrees, sine is 0. At 270 degrees, sine is negative 1. And at 360 degrees, sine is 0. So if I was to graph sine, it looks like this. And this is, once again, sine of theta. That's a whole cycle. Remember what I mean with cycle. Let me highlight the cycle. If I was to go to the right, it will continue going like this. If I was to go to the left, it will continue going like this forever. So let me just show you guys one cycle. And once again, there you guys are going to be introduced to this word called amplitude, or not amplitude, my bad, period. The period is how long does it take for one whole cycle. Now amplitude, because we're also going to use the word amplitude, is how high and how low did it go. If you notice, it goes as high as 1 and as low as -1. So my amplitude from the x-axis, it goes up 1 and 1 down. So my amplitude in this case is 1. We're going to mess around when we make the graph go higher than 1. But if it goes higher than 1 to above the axis, you should go the same quantity down. So my amplitude for cosine and sine, remember, from the x-axis, how high does it go? 1. How low does it go? From the x-axis, 1. My amplitude is 1. Period, once again, I said it's how long does it take for the graph to repeat. We're going to mess around with the period as well. And then we're even going to learn how to graph these. Let me erase this on the top. There's something I'm going to mention. I'm gonna give you guys equations. I want you guys to know the equations of the graphs. I want you guys to be able to identify the graph. I can give you something like y equals, and let me just call this a. My a will be a number, any number that I want. And then let me call this b theta. My b will be any number plus c. And then let me add a d right here at the very end. I want to talk about the values of a, b, c, and d. A, b, c, and d are going to be numbers. It could be fractions, it could be a whole number, it could be anything. Now, this number outside of the parentheses is my amplitude. Remember how I had my graph, my amplitude was 1 originally? If I put a number outside of my parentheses, that's the number I'm going to multiply my amplitude by. Originally was 1, so my amplitude times 1, that gives me my amplitude of my function. Now b is going to talk about what we call the period. Now b, notice how degrees is 360. For a whole period is 360. Now for b, the period is going to be 360 divided by b. Whatever number it is. Notice my b, I wrote it as a number in front of the theta. So I'm going to divide 360 because that's how long it takes for a whole period. I'm going to divide it by b to know how long is the period now. Now for c, this talks about shifting. Now remember how when we used to graph functions before, remember when we saw parabolas or absolute values or things like this, we used to move in right and left. This is shift horizontally. Opposite signs though. If I had like a +3, I move 3 to the left. So this number inside my parentheses, but not next to theta, it tells me how much to move, how many degrees to move. But remember, we're looking at this as opposite sign. So if it's plus, you move to the left. If it's minus something, you move to the right. Once again, we think of this as shifting horizontally. So my graph is going to move sideways. Now this number, sometimes I'm going to have it by itself at the very end of the equation. Sometimes it could be at the very beginning. I could move my d to the very beginning, or sometimes I can have it at the end. Now this is shift vertical. Now this number is going to tell me up or down. If it's a positive number, I move up. If it's negative number, I move down. So those are basically information we're going to need. For the beginning, let's take a look at our notes. The first question. Here I'm just asking, find the amplitude. Remember I said amplitude, I call it the number outside of the parentheses. Technically right now I have a 1. Oh, I forgot, I'm going to have either sine theta or cosine theta here. That just gives you an idea how the graph looks like. So my amplitude in front of cosine is a 1. So my amplitude in this case is 1. Now, when I look at number 10, my amplitude, right, the one number in front of cosine, it could be cosine or sine. But the number right in front of, in this case, cosine, my amplitude is 1 over 7. So the way I will type that is 1 over 7. Before I move on, I want you guys to look at this number 10. That number, that negative 1 in number 10, that's my D. Remember when I talk about A, B, C, D? And I said my D could be at the very end, like it is in number 9, or it could be at the very beginning, like it is in number 10. It is a number that has nothing to do with the parentheses. Between that number and a parentheses, I see a plus or minus in between them. So, but question number 9 and 10, we're just looking at the amplitude. But I just wanted to emphasize that my D, the shifting vertical, could be at the very end, or it could be sometimes at the very beginning. All right, so let's continue. Let's take a look at number 11 and 12. Now here, I'm asking, use degrees, find the period of each function. So I'm just going to be looking at this first part. Notice how I have theta, that's my B, but remember I have theta by itself. So in reality, what I have here, instead of theta over 6, let me look at this as 1/6 theta. I'm going to take theta out of the fraction. So I have 1/6. So we can tell that my B in this case, remember when I talk about A, B, C, D, B in this case is 1 over 6. Remember I came and I said the period is 360 divided by B. So let me call this 360. I'm going to write it as a fraction divided by 1/6. Now, when we divide fractions, don't we just multiply by the reciprocal of the second fraction? Let me just call this 360 over 1 times 6 over 1. Remember, when I divide by a fraction, don't I just multiply by the reciprocal of the second fraction? Now, I know 360 times 6 is 2160. 1 times 1 is 1. 2160 over 1, I'm just going to say 2,160 degrees. Now, what does this mean? It's going to take 2,160 degrees to complete the whole cycle of sine. Remember when I came in, I talked at the beginning, when I highlighted the cycle, it took us 360 degrees. Now we expanded it. It's going to take 2,160 degrees to happen, the whole cycle. Now let's take a look at number 12. For the amplitude, I'm looking at this. I'm just looking at 1 over 7 theta. Remember, I removed theta from the graph. From the fraction. 1/7 over theta. And I said the period is 360 degrees divided by B. So I have 360 over 1 divided by 1 over 7, which is better known as 360 over 1 times 7 over 1. Now, some of you guys might be saying 360 over 1 times 7 over 1, isn't that the same thing as 360 times 7? Because over 1, 360? Sure, 360 times 7. So question number 11, we could have just done 360 times 6. Sure. Now, 360 times 7 happens to be 2,520. Now, in these examples, our numbers became more than 360 because a number with a theta was a fraction. It's a fraction less than 1. Now, sometimes in your answer, if my b is more than 1, your answer should be less than 360. You guys are going to see that sometimes. All right, let's take a look at number 13. For number 13, I'm going to need my A, my B, my C, and my D, and how the graph looks like. So to begin with, I'm dealing with cosine, so I know how the graph of cosine looks like. All right, that's the graph of cosine. I need to know the period first, and I need to know the amplitude. I'm just going to say my amplitude is 3. The period, I'm going to say the period is, I'm looking at 360 divided by 1/2. So 360 times 2. The period is 720. It's going to take 720 degrees for the whole cycle to repeat. Now, for my C, I'm going to move this 60 degrees to the left. Right, 60 degrees to the left. So, and then I'm going to move, I see my D is -2. I'm going to move 2 down. My shifting horizontally, 60 degrees to the left. My shifting vertical is 2 down. All right, so cosine. Remember how it initially started at 1? So what I'm going to do, I'm going to move it 60 degrees to the left. So as a matter of fact, let me start. Let me start with my period actually. To begin with, it takes 720 degrees, I said, right? 720 degrees for the whole cycle. Now 360 is right there in there. That is just, if you follow along those dots that I did, that gives us what originally it is by changing the period. Now amplitude, I'm going to change this to 3. So actually, my zeros, I said it was going to be there. So this is how it originally looked like, right? Now my amplitude is 3. So instead of going to 1, it's going to go all the way to 3. It's going to go at 0. It's going to go all the way down to -3. Going to stay at 0. It's going to go all the way up to positive, oh, not 720. It's going to go all the way up to +3. Kind of have an idea. So I took care of my period. It took 720 degrees for the period to repeat. My amplitude is 3, so it went all the way up to 3, all the way down to -3. Now I have to move everything to the left 60 degrees, and I have to move everything down 2. So let me start by moving everything down 2. Right, I have to move everything down 2. So each of my points, let me go there. So let me erase these points. Right, I move everything down 2. Now I must move everything to the left 60 degrees. So I noticed that each box is 90 degrees. So to the left 60 degrees, I'm going to move this about, we're going to say it's about here. Roughly it's about, and if I could graph that there. Now following the picture of cosine, and then obviously I continue. All right, let's take a look at sine. Let's take our graph from sine. Let's take a look at number 14. Let me worry about the period. I'm looking at this right here. Remember, I have to go 360 divided by 1/3. So it's basically 360 times 3. That gives me 1,080. So I'm going to take a whole cycle, 1,080. My amplitude is 2. So let me take care about the period and amplitude. It's going to go as high as 2. But looking at sine, it starts at 0. And it's at 0. Right in between them is 0 again. Remember, I'm looking at my sine, my 3 zeros. It begins at 0, it ends at 0, and right in between them, it's 0. Now, because my amplitude is 2, I'm going to say it goes as high as 2, and then it goes as down as 2. That's how it is originally, taking care of the period and the amplitude. Now, let me focus on the shifting vertical. Everything is going to go down 1. So each of these points, I brought it down 1. That's my shifting vertical. My shifting horizontally, I'm going to move 210 degrees to the left. So let's see, let's move this point. Let's move this point right here. Let me move it as in red. I'm moving it 210 degrees to the left. So my graph should look like that's how my graph should look like. Your graphs are going to be multiple choices, but I want us to start practicing on what does the amplitude does. From 1 to -1, it makes the amplitude go higher or lower. Now, what does the period do? How long does it take for a whole cycle to repeat? And then there's shifting vertical and shifting horizontal.